Hello everyone, welcome back again. So today I would like to explain about a brief matrix algebra. So the basics. So R, Julia, Mathematica, and MATLAB as of today. Okay, quick brief overview. This is the disclaimer. Again, I try to make my best, but again, this is provide as is without any warranty. Okay, so this doesn't mean that it will replace the theoretical or more rigorous textbook. This is just a brief introduction. Okay. So again, this is my basically brief background. I learned some language, but basically I'm not a computer scientist, nor I'm also nor engineering. So this is based on my work. So I assume that you need to understand some basic metrics here. But high school mathematics level, I think it's enough because I also, again, I'm not the, I didn't learn any algebra basic unless I learned in the high school and basic R, Julia, Mathematica, MATLAB again here. Okay, I give some information. Of course, I take some material here from the Nick Filler here. Sorry, Filler Basics of Mathematical Algebra. Sorry, this is a typo. Yeah, Basic Algebra for Statistics with R. This is a good and more detailed information. And matrix algebra actually is used heavily in the econometric analysis, especially in the green. And because I also use Mathematica, I will frame Mathematica. So this is also good reference. Sabo again, linear algebra survival guide here. So again, basically the topics I would like to discuss today is the factor and matrix here. And then also the second is the common issue in the matrix here. So let me quickly here. So you will see here. Okay, let's go quickly here. So let me divide it by two common issue in the matrix here. So factor and matrix, and then also the common issue in matrix. So this is the big topic here. So I would like to update here. Okay. So the factor and matrix, I will cover factors, matrix, joining matrix together, dimension like of matrix, arithmetic, transport, and also trace. And common issue in the matrix, I would like to explain how we implement the determinant, inverse, eigenvalues, and eigenvectors, decomposition, and also linear system example. Again, this is just quick brief overview. So let's go to the factors and matrix. So I will go quickly again to the to the R. Okay, so this is the R screenshot. You can have a look so you can make it bigger. Okay, so this is the code. So let's delete. So basically for this is the factor. So factor basically is a line. So you can have a look in here. Okay, yeah, but I cannot make it bigger. Yeah. Okay. And then for the matrices is the this is row and column factors. For the matrices here, you can make it quickly. Yeah. Example. So in the R, if you want to join matrix, you see column bin and row bind here. Yeah. Okay. So you can combine two matrices, in this case A and C. So if you want to know the dimension, you will use dim command and also length for the factors. So you can see for the factor A, the dimension is null because the more appropriate is length here. So element by element, we can use A plus C and then A minus C. You can use two scalar multiplied by the matrix and then try A and C. Yeah, it's element by element. But for the A and B, it doesn't work because the array is not conformable. But the A and B, we can use the dot and then cross, we can use dot product here. Again, what is the dot and cross product? You can see the detail in the matrix algebra. Okay, we assume you have already know. So I just want to know that we can do in R here and either for software. So for the cross, we can use library Pragmaya. So if you have a CA and CB, you can like write what is CA. CB is the factors matrix, so column factors. So you can see, you can cross CA and you can also do the Kroger product here. So for the yeah, Kroger, you can get Kroger with this Kroger. Perhaps my spelling is correct. Okay. The next is the transpose. So easily you can use TA and TB. And then how about trace? So if there is a phi metric, you can also easily use the sum of diagonal phi. You can get 13 of the trace. Okay, that's how you work in the R. how you work in Julia. So let me open again the command in the Julia language here. Okay, let's go. Wait. Okay, so let's go to the Julia here. It's nice. Okay, so the first you need to use the linear algebra here. Okay, so here we go. Where is it? This is it. Okay, and then the command is I show you. This is the Julian. I wrote in a notepad, so let me make it bigger. Oh, sorry. So this is the Julia. So it nice factors matrix here. You can see here. So let's go copy one by one. You can see also the factor and matrix. You can go to the Julia. Okay. Okay, factors. Okay. So yeah, matrix. You can also see here. Okay, it's nice. You can see. And then also for the joining matrix, you can see horizontal and vertical cap. Next, for dimension, you can use size. And element by element, you can do again, as usual. Just don't forget to use A point plus C, A point, and minus C, magic 2 multiplied A, and then A multiplied. Just be careful again, A and B doesn't work because dimension mismatch. So Julia will provide the reminder, the warning errors. And dot and cross products you can use in Julia as well. So A multiplied by C, A, C, B, and then you can cross A and B. Conquer. So you can also use easily conquer A or N. You get quickly. How about to transpose? Again, you can see Julia transpose A, transpose B, and then trace over the factor. You get easily trace TR using phi. That's in the Julia. Okay, how about the Wolfram Mathematica? So we can also use the Wolfram where is the Mathematica? Okay, so here we go. You can see again. This is, so let me make it bigger here. Oh, sorry. Okay, so metric form you can see here. So make a metric form. Just I make it nicely in the Mathematica. That's why I like Mathematica is the layout is very nice. So you can see matrix here, metric. Even the how you write this must be in what is this? How can I see? These characters bracket. So joining metric is the metric form. So this is a little bit tricky because in Mathematica you need to know a little bit transpose. So column bin is a bit more tricky. So for the row bin, it's much easier. You have A and CC metric, you just join A and CC, that's finished. But for the column bin, you need to be transpose A first and then transpose CC, and then you join and then transpose. That's the logic. So first you need to transpose the A and then transpose the CC, and then you join and then transpose it. This is what I bit dislike in here. But anyway, it works. So dimension again, size, you use dimension, a bit long work. Yeah, okay. Element by element, you can use A plus CC, A means IC, 2, just 2 multiplied A, because Mathematica is designed, looks like a mathematic 2x to Y, don't worry to the stars. It's AC, okay? How about the dot and cross product? You can use metric form dot AB. Okay, you get it? And for the metric form, you can see like this. Okay, if you want to see what is this here, okay, so you can see CA is factors, CB is factors, so you can get cross CA and CB. You can also get Kronecker product here, and then transpose is also simple. You can see again, Mathematica is within the layout here. Trace you can also use trace of this. Okay, let's do the last part, how we implement in MATLAB. So let's open. Where is my MATLAB file? Okay. Oh, sorry. Oh, sorry. Where is my MATLAB? Lovely. Okay, so let's clear all. And then the factors, again, the name is MATLAB, Mathematic Lab Brother, so we can see nice for the factors. Okay, you get the factor A, factor B, you get matrices A and B as well quickly here. So let's see, this is the for those who are the fan of the MATLAB. So you can join the metric A, comma C, and this is MATLAB. It seems much very easy. If you want to join A and C in the column bin, it's just A, comma C, and then if you join what is row bin, you just A and then dot point and comma, and then you get this one. Okay, and the dimension and length is size. You can write size, you get the dimension here, 2 3 3 2 2 3 1 3 3 1. So this is that's why the name is MATLAB metric. So since the history MATLAB use for the metric is very convenient. So and then you can see A plus C, A minus C, 2 multiplied A dot C, and then A B. This is again doesn't work because not compatible. Okay, if you want to do dot product, you can just A multiplied B, you get it. So for the cross, again, cross CA and CB. Cross is pretty simple. Again, cron A to metric here. Transpose again, transpose A, transpose B, you can easily. Trace again, phi metric, you get easily in here. Okay, that's all. Let's go. The next is, again, this is a brief, so just a refresher. Basically, you will get an idea that actually you can implement any metric algebra in this for software. Okay, let's go. The determinant is E, F, G, H here. Okay, with yeah. Okay, E, F, G. You can see that D, A, T, and then if there are four metric, you inverse is using. You can using solve. It's pretty easy in R as well. Okay, yeah, you can just be careful for the K doesn't work because you can see again singular, again the property of the metric. Eigenvalue is also easy. Eigen P, you get the eigenvalue. Just be careful when how the software present the result and interpret the result. There might be minor differences. So again, double check with the example and the manual to get more precise understanding. Okay, but basically you can get the eigenvalue, eigensystem, and also we can see here like eigenvalue, eigenvalue. Singular value decomposition we can also find here. It's quickly. And then for the case of non-square metric of rank, you can also SVD, singular value decomposition. Key R decomposition, it's pretty easy. Also key R of the metric. LU decomposition, we can easily get, but in the R you need to add metric packets here. So LUY. Okay, a little bit take long. Yeah, you get it. So the okay. So you might need to write also expand if this is okay. You get it, the number. Okay, Cholesky, the conversation. This is the famous one again. So you get quickly the number. So finally, let's try to solve the linear system, the simple one. Of course, if you want to go to more advanced, you can develop yourself. You can see, okay, if you can see A, and then B, you can solve quickly. Blah, get it? This is the basic. Okay, can you do in Julia? Of course, why not? If you want to do Julia, let's go again. Where is the nicely Julia? I wrote everything. Okay, yeah. Okay, so let's go. I will open here in the Julia language here. Where is it? Okay, let's go for the determinants. Yes, okay. Okay, you see this is the metric. So the determinant is just that. Yeah, okay, you can see clearly that here. Okay, so Julia inverse. Okay, so let's have IGKLM inverse. So pretty easy. We have inverse IG. Okay, only inverse K. Again, it's singular metric. Okay, it doesn't work. Clear. Eigenvalue and eigenvector. There is 10 eigenfalse and eigenfacts. Eigenfacts, yeah, facts. Okay, you get it. Oops. Yeah. A singular value decomposition is also pretty easy in Julia. You can see SVD. QR decomposition you can also use pretty easy, QR. But don't forget again using the linear algebra metric. How about the LU decompositions? Yeah, and then for the Cholesky. Okay, The last is linear system example. Again, this is just the basic logic metric to solve. You can find easily. Okay, let's go to implement. How about we implement this in Mathematica? Okay, mathematical from that slice list. Okay, we can see go. Okay, suppose there are matrices here. So determinant in F1, you get 0, -7, and X. Suppose there are inverse again. Mathematica nicely report the metric form. Yes, so you can see clear. From K again, I sometimes it doesn't work. If I cannot use like I will use double I. That's all. Okay, so the inverse doesn't work again here. L again, this is union. Very mathematic. That's why the name is Mathematica. Very precise. Okay, eigenvalue and eigenvectors. Here you can see P, Q, R. So just write eigensystem P, eigensystem Q, eigensystem R. You'll get, and then okay, let's go to the more advanced topic like singular top value ST. So just singular value decomposition. Let's see if I write without and sorry, a bit longer. Woo, you can see this. Yeah, I think it's very, very precise, but sometimes so precise probably is difficult. Okay, just N. This is similar. If you are not using L, you can use singular value. You will get with. This is nice number here. Okay, QR, you can see there is a metric here, and then you can see the composition you can get again. LU, you can also use LU, the composition here. Okay, the number. You can also try if you want to report in the metric form. Let's see. Okay. No, it's not circles. Oh, wait. Okay, something. Okay, anyway. But you can be Cholesky something like this. And Cholesky, the composition is like this. Okay, if you're not using, you can also use like this. Yeah, okay. This is more precise. Yeah, if you wise. And then the linear system example, we use the AA, CC, BBB, and then linear solve. Okay. Let's go. The last how we implement in MATLAB. Lovely. Okay, so again, the determinant, you see there are some metric here. Okay, here we go. We will get K, and then inverse simple. K inverse INV. Determinant is DET. So inverse is INV. So it's much easier. You get quickly. Eigenvalue, eigenvector. So IEG, you get it. Just this is a bit of variation of the report V and D. Again, you need to read the MATLAB manual, yeah, to show detail, but basically it's possible. There are some minor variation in reporting result. Singular value decomposition, you can also report this one. KR decomposition, you can also use. KR, L and U, you can also report like this. Cholesky decomposition, Y, Z here. And the last, let's go to some practical example. For example, in the linear system is this. Okay. So that's all. I think you will enjoy, and if you wish to use to implement a matrix algebra, linear algebra or matrix algebra in software, like you have at least 4 choices here. You can use in R, you can use in Julia, which is both are free. If you have a fan of MATLAB and Mathematica, it's also good. However, again, they are proprietary. You need to pay. Okay. So thank you very much. I hope this is useful. Thank you.